show how a current generates a magnetic field, we first create the current by connecting the circuit by connecting the positive end of a battery to the negative end of the battery. Then as you bring the compass towards the current carrying wire, you see that there's a deflection in the compass, which shows that a magnetic field is created. To show that a current flows through a circuit, we use a light bulb, 2 batteries, and wires connected to the positive end and the negative end of the battery. When you connect the wires to the light bulb, it completes the circuit, and this is shown through the light bulb lighting up. When the light bulb lights up, it shows that the current is flowing through the whole circuit.
To create a simple motor, we use a battery, a magnet, and a loop of wire. So to complete the circuit, you place the metal loop in its stand, allowing the current to flow from the positive end to the negative end. Now, once the current is flowing from positive to negative, we can use the right-hand rule to see how a force can spin the loop. At the top of the loop, the current is going in this direction because positive is here, negative is here. So at the top of the loop, the current will be going in this direction. The magnet is going to create a magnetic field that points up. So we point our fingers in the direction of the current, curl our fingers in the direction of the magnetic field, and our thumb points in the direction of the force. So at the top of the loop, we have a force going this direction. At the bottom of the loop, we notice that the current spins in this direction around the loop. So at the bottom, the current is in the opposite direction, but the magnetic field is still pointing up. So we point our fingers this way, curl our fingers in the direction of the magnetic field, and our thumb will point in the direction of the force. So at the bottom of the loop, we have a force in this direction. Since at the bottom of the loop, the force is in this direction, and at the top, the force is in this direction, it will cause the loop to spin in one direction, which we're about to see. And that's how a simple motor works.
In order to wire our board, we first drew our circuit out on a piece of paper in a simpler way. As you can see, our board was wired in a parallel circuit with 4 different branches. On our board, we first wired our in outlet to the main switch of the board to allow the current to flow throughout the board. It was then wired, the first branch was wired to the first switch for the series of light bulbs. There were 2 light bulbs connected in a series because each can only take 12 volts and our generator produces 24. Therefore, if there was only 1 bulb present, there would be too much voltage and the bulb would burn out. Our second branch was then wired to a switch for the second series of light bulbs. Our third branch was wired to the voltmeter, and our last was wired to the switch for the out outlet. Each branch was then wired back to the ammeter, which was wired to our in outlet in order to complete the circuit. Go.
A bike generator is a bicycle which is attached to a motor by a belt. As a person pedals the bike, the belt spins the motor, which is shown over here. Inside this motor, there are metal coils that surround a magnet. So when the bike is pedaled, the coil spins around the magnet, which causes the magnetic flux to change, which in turn causes the current to go through the electric board we have here.
Okay, so the way our board is set up, we have a main power switch, and when it's off, it's not allowing any current from the bike generator to flow into our board. But as soon as it's flipped on, then any current that is created by this bike generator, like how we previously explained, is allowed to flow into our board. Then we also have switches for each set of light bulbs. This switch will allow current to flow into these bulbs, and this switch will allow current to flow into these bulbs. And this switch allows our out source to work. So as the individual starts pedaling, current begins to flow into our board, and the bulbs begin to light up. And this can be seen through voltmeter and ammeter readings also. Our hypothesis in our experiment was that as the person pedals faster, more voltage and more current will flow into our board, causing an increase in power that is put out by the board. So we tested our hypothesis at a slow speed, a slow pedaling speed, a medium pedaling speed, and a fast pedaling speed. So when she's pedaling slowly, we can observe that the bulbs are not lighting up very much. But as she starts to pedal more quickly, the bulbs start to light up more. And then when she starts pedaling very quickly, we see that the bulbs light up a lot. So this shows that as she pedals faster, the bulbs do light up more, and it shows that our hypothesis is correct.